Welcome back. This is the day the Lord has made. Let us rejoice and be glad in it. This is the second video of my organic chemistry lessons. So in this video, we're going to focus on organic nomenclature. Organic nomenclature is a big fancy way of saying, how do you name the molecule? I'm biased, but I'll say that I love organic chemistry when it comes to naming. Organic chemistry is the most organized and systematic language in the world. By the time we're done with this video, you will have a bigger vocabulary in organic chemistry than you will have in English. Because the thing about organic chemistry when it comes to naming stuff is there's a reason for everything. Every part of a word means something. All right. And it's also like there's no exceptions. Like there's a rule of like how this is done. And if you follow the rules, you get the right name. All right. So again, I love organic chemistry naming. It's fun to do. It's easy to do once you figure it out. But again, by the end of this video, you will have a bigger vocabulary than English. So anyway, and thank you, IUPAC, for coming up with this stuff here. And I should also mention too, the reason it's so organized is because it's the medical language. All right. So when you're making molecules for like medicine, it makes a big difference what the molecule's formula is. And if the formula changes just slightly, even if you take a halogen and change it from one carbon to another carbon, you get a new chemical. And so it's really important that when you're communicating to someone else about the drug you're making or about the chemical formula and the name, it has to be exact. You can't have it, whoops, sorry about that. I meant to tell you that the alcohol should have been on the third carbon, not the fifth carbon. All right, mistakes like that are not good. Anyway, so there are three parts to a compound's name. So there's going to be the base part of the name, which I'm going to often refer to as the root. The root of the name, that's going to be how many carbons are part of the molecule. How big is that chain? So methane, ethane, propane, butane, the root of that is the first part, like the meth, eth, prop, bute. That's telling you how many carbons are inside of it. All right, so again, the base part of the name, the root part of the name, it's going to tell you how many carbons are inside this molecule. The suffix, that's going to be what family it belongs to. So there's a lot of families. In this class, we're going to focus on just a couple families. We're going to focus on alcohols and focus on like alkynes and alkenes. We're going to focus on double and triple bonds and alcohols. Now, when you go into higher levels of biology and chemistry, there's a lot of other functional groups that are important to know. Like, for example, amines. You know, those are really important because like amino acids. Amino acid just means it has the functional group of amine on it, NH2s. That's all it means. But it's in this class here, we don't have time for that. We're just going to talk about alcohols and double bonds and triple bonds, and that'll be the suffix. That'll be the family. Now, we should also mention you can be part of more than one family. You can belong to the double bond family and to the alcohol family. That's fine. And so we'll talk about how to name that stuff. So it's no different than like I got married to my wife, and she has a family, I have a family, and we came together. Both our families are now together, and so I'm actually part of multiple families. I have my immediate family, my wife's extended family, and my extended family. So you can be part of multiple families. So same with organic molecules. And then the prefix, this would be where we say like, what else have you done to this molecule? Again, back to those functional groups. Have we added something else to this besides a hydrogen? Did we take a hydrogen off, put something else onto it? Those would be the prefixes, things we've attached. All right, so first, you should know about these roots. These are the organic base things that you should be aware of. These are just how many carbons stands for. So meth means 1 carbon, eth means 2 carbons, prop means 3, bute means 4, pent means 5, hex is 6, hept is 7, oct is 8, non is 9, and dec is 10. So like, for example, octane. You're talking about going to the gas station and you're filling up your car with fuel. You're filling it up with some mixture of heptane and pentane and octane. That oct just means 8 carbons. It means that the molecule coming out of that pump has 8 carbons long in it. So it's 8 carbon long molecule, octane. If it was 7 carbons long, it'd be heptane. If it was 9 carbons long, it'd be nonane. So those are the organic groups you should be aware of for this class. So the organic families in this class you should be aware of, there's ane, ene, ine, and all. So if something has a single bond, only single bonds between the carbons, we'll just end in ane. So like when we say eth, ane, there's 2 parts of that name. The eth is the root of the name. Eth means we have 2 carbons. The ane means that we have single bond between the 2 carbons. So if we say propane, prop is the root, 3 carbons. Ane means that we have all single bonds. If you change it to ene, now you mean you have a double bond. So if you say propene, you're saying that, okay, we have a 3-carbon long molecule, and the ene means that we have a double bond on it too. We'll talk more about that later because we actually have a numbering system to say where's it actually at. And same thing with ine. If you say butane, you mean that there's all single bonds. If you say butene, you're saying there's a double bond in there. If you're saying there's butyne, there's a triple bond. And if you change the name at the end to an all, then you'd actually put, you just like, ethanol. So when you say ethanol, you're saying 3 things actually. Eth means that we have 2 carbons in the molecule. The ane, ethan, the an means it's single bonds between the 2 carbons. The all means that we have a hydroxyl on it, an OH. So when you say ethanol, there's 3 parts in that name that tell you what's going on. So some of these things here are families. Some of these things are just attachments. And you don't need to know all of them. So again, the top one here, alkane, just means this family is single bonds. Alkene, double bond, alkyne, triple. Alkyl halides, this is not a family, but it's going to be a prefix. So something you might attach to it, an alkyl halide, fluorine, chlorine, bromine, iodine. We're not going to talk about amines, but an amine just means there's an NH2. This would be a family, all right? So for your future biology your future biochemistry amine just means NH2. Alcohol, we will talk about these. This means that there's an OH attached to it somewhere. That's a family. And these other ones here too, you'll need to take a look at this to answer some of the questions about general functional groups, but you don't need to memorize these ones. But again, as you go into higher levels of chemistry, you'll come across them. And you've heard about these before. So like ether, aldehydes, ketones, like, when you hear a ketone, it ends in "one," like acetone. So acetone is a ketone. All right, so how it ends, it tells you the name of it. Carboxylic acids, again, really important for DNA stuff. Esters, amides, these are just different functional groups that you can change the flavor. So organic substitutes, this is when you take a hydrogen off and you replace it with something else. So this are the things you put on the front, the prefixes for the name of it. So in this class, we're going to have 2 options for things we can add that would be a prefix. We can have halogens added onto it. So, and this is the proper spelling for the fluorine. Sorry, on my last PowerPoint it was misspelled. Again, just going to caution you, watch out for your autocorrect speller when you're typing in organic names. When you type in fluoro, it's going to change it to flower. All right, so and also bromo, your computer might want to make it broom. All right, but you should tell your computer you're speaking organic chemistry now. All right, so if you had an alkyl halide, you're going to put fluorobromor or chloro wherever it's at, and if there's another carbon chain, so again, carbon can make branches. So if there's a main carbon chain and another carbon chain comes off it, all we do is we put a YL at the end of it. So if there's a 1 carbon coming off the main branch, then it'd be a methyl. If it's 2 carbons, it's an ethyl. If there's 3, it's propyl. And so we have some examples coming up here for you to see this. Now, it's not enough just to say that it has it. We need to know where it's at, because it's different, has a different personality based off where you put those things attached to it. And so organic chemistry, we use a numbering system with a dash saying where's it located at. All right, so for example, if we say 2-fluoro, 2-fluoro says on the 2nd carbon, there's a fluorine. So rather than that 2nd carbon have all hydrogens being saturated, we've taken a hydrogen off the 2nd carbon and added a fluorine to it. All right, so think about this name, 2-fluoropropane. On the 2nd carbon, there's a fluorine. The root of the name is prop, which means it's 3 carbons long, and the ane here means we have single bonds. So again, another example, propan-2-all. When you say this is now saying that we have an OH on the 2nd carbon. Do take note when I spelled this out, the prop stayed the same. This means we have 3 carbons. Instead of having A and E, I took off the E here, put a dash. So prop means 3 carbons, and means single bonds. -2 means on the 2nd carbon, we have an OH. If you have multiple things of the same type, you add a di in there. So looking at this molecule here on the 2nd carbon, so carbon 1, carbon 2, carbon 3. On this 2nd carbon, we have 2 fluorines attached. So again, it's really important, because this is for medicine, that we need to know exactly what the chemical formula is and where everything's attached, because it matters for people staying alive, all right, and when we're making these things. So if you have 2 fluorines attached, you would say 2, 2. What this is saying that on the 2nd carbon, we have a fluorine, And on the second carbon, we have another fluorine. And as a double check, we put di here. So di says, it's just a double check saying, hey, you should have two numbers here. So 2, 2 dash di fluoropropane. If we'd had a third fluorine on here, it would have said tri. So just to say, hey, make sure that there's 3 numbers there. Okay, so when you have multiple things, you just put a comma between them. So 2, 2 means on the 2 and the 2, we have a fluorine. The di is just a double check. Okay. You can have multiple attachments that are different too. So on the last one, we had 2 fluorines. Here, we actually have 2 different things that are attached. We have a chlorine and a fluorine. When it comes to multiple attachments, what you're going to do is you're going to put them in alphabetical order. All right. So we're going to put the chlorine before the fluorine. So it's 2-chloro. This is saying that on the second carbon, we have a chlorine attached. This is saying that on the second carbon, we have a fluorine attached. And so this is also helpful when you're looking at a chemical name. Do I have this attached or not? You just look at the prefixes in alphabetical order and be like, oh, yes, yes or no. Okay. So the prefixes can get really long. So here we have 2-chloro, 2-fluoro. That's the prefixes saying here's what's attached. Prop means it's 3 carbons long, and the ane means it's all single bonds between the carbons. You can also have multiple families that are attached to it as well. And so for the multiple families, same thing, we just use commas. So here we have 1, 2, 3, 4 carbons. So the root of this thing is going to be bute. We have 4 carbons long. All right, between the carbons, they're all single bonds. How do we know? Because of the number of hydrogens and the number of bonds. So this carbon here on the end has 1, 2, 3 hydrogens plus a carbon. That means that this is a single bond. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. Since all the carbons have 4 bonds, then it's all single bonds. So bute and, meaning we have single bonds. Then on the first and the third carbon, we have an alcohol. So we're going to say 1, 3 dash di. Again, the di is just a double check that we actually have 2 numbers here. And then we're saying the family attached, the all. So again, notice I did drop the E again from the front. So it's not butane, it's butan dash 1, 3 dash diol. So on your homework assignments, you're going to be getting things that look like a condensed formula, and you're going to name it as such. And so you're going to basically have to figure out how long is my chain. So here we have some chemical formula. Now this is like a condensed formula. That means that the carbon, whatever comes after the carbon, tells you how many, what's attached to it. So this carbon here has a bromine and 2 hydrogens. This carbon has 2 hydrogens. This carbon has 2 hydrogens, and so on and so forth. We found to see that, oh, this carbon here has a bromine and an OH. So there's an O here with an H. So that's an OH. And then this carbon has 3 hydrogens. So again, that's how that's written. First, we got to identify how long the chain is. We're just going to count carbons. So we have 1 carbon, 2 carbons, 3, 4, 5, 6, 7. We have 7 carbons long. That tells us that the root is going to be hept. The root of the name is hept. Now let's find what else is on there. We see we have bromine in 2 places. We have a bromine here, bromine there. We also have an OH. Now we got to figure out how to name this thing. Now there's a bunch of rules about who gets the lowest number. So in this class, alcohols are really, really important. They are guaranteed the lowest number. So when we label the carbons here, we're not going to give this carbon here on the left the lowest number. We're going to give the carbon on the right the lowest number because we want to make sure the OH gets the lowest number. So again, there's a huge tier list of like what molecules, what functional groups get the lowest one. In this class here, OHs get the highest precedence. After OHs come the double and triple bonds, they're tied. Then after that is the halogens and other things that are attached. But in this here, we want to make sure OHs get the smallest number. So we're going to say that this is carbon 1 then, and then this is carbon 2. So on the second carbon, we have an OH. So we're going to say that hept and dash 2 dash all, we're going to make sure that the OH gets the lowest number. Then we're going to find where the bromines are attached. So this bromine is attached on the 2 carbon, 3, 4, 5, 6, 7, and on the 7th carbon. So we're going to say 2, 7 dash dibromo. So again, we're saying that on the second carbon, here's that second carbon, and on the 7th carbon, there's a bromine. There's 2 of them, dibromo, hept, meaning we have 7 carbons long, and meaning it's all single bonds, because now how do we actually figure out that they're all single bonds? By looking at this formula. Again, see how many things are attached to the carbons. this carbon here has 3 things attached plus this carbon, so that makes 4. This carbon here is attached to this previous carbon and attached to this carbon, so it has 2 things also room, and it has that. So 2 hydrogens plus the carbons on each side. So if it was only 1 hydrogen here and only 1 hydrogen here, then it'd be a double. If there was no hydrogens, it'd be a triple. So again, just more examples, naming some compounds. So here we have it drawn out for us. We're going to find the longest chain in the molecule. So it doesn't matter whether we went here to there or here to there, but the way it's drawn out, we have 1, 2, 3, 4, 5, 6. That's the longest chain. Now we're going to number the chain. Now we want to, if you just basically want to make sure you use the lowest number possible. All right. So we only have 1 thing attached to it. Because we only have 1 thing attached, we're going to give that thing the lowest number. All right. So we're going to say that on the second carbon, there's another branch coming off here. So we have our main tree, and then we have a branch. That branch stems from the second carbon. So when you name things that are like hydrocarbon things, what you do is you just change the ending to YL. So this is 1 carbon, which is meth, and we're going to put a YL to say it's something attached to the main chain. So, and where is it attached? On the second carbon, 2-methyl hexane. So the 2-methyl means that, hey, we have a branch, which is a carbon with hydrogens on it. And it's one that how big is the branch? 1 carbon. So it could have been a bigger chain. It could have had more carbons on it. So, and then we're saying the hex means that we have 6 carbons long, and the ane means it's all single bonds. So we can have multiple things here attached too as well. So this is a little more complicated. So we already have it numbered out. We have 1 carbon, 2, 3, 4, 5, 6, 7. Our longest continuous chain is 7. So you'll see that we have on this part right here, there's actually a branch that came off that wasn't part of the main chain. So if we'd have counted this way, it wouldn't have been the main chain. Oh, sorry, if it went this way, it wouldn't have been long enough. That's 5 carbons long there. We could have also went either way. We could have went this way, but then we'd had a more complicated naming of this. So naming this here, we see that 3-ethyl, we're saying that on the 3rd carbon, we have 2 carbon long branch. So that's, and again, with the YL to say it's an attachment. So 2 carbon long attachment on the 3rd carbon. Now we also have on the 2nd carbon a methyl, on the 4th carbon a methyl, and on the 5th carbon a methyl. So we're going to say 2, 4, 5, try. Again, the try is just a double check, like, did you really want to say 3 numbers? So like if you said try, but you had 2 numbers, you made a mistake in writing the name. All right, and what's attached? We have 3 methyls attached onto what? Our 7 carbon long molecule, which has all single bonds. So again, it's a mouthful to say. 3-ethyl, 2, 4, 5 trimethyl heptane. It's a mouthful, but it says exactly what the molecule is. And this helps us communicate, to someone else who's never even heard the word before, what it is. So if you're reading some book and you came across a word you never even heard before, any part of it, you'd have no idea what it means. In organic chemistry, you actually know what the molecule looks like. The name tells you exactly what it looks like. Even if you've never heard of it before, you know what it looks like. So this is just an example of an alkyne. So for alkynes, we're just going to put a YN in there instead of the AN. So we're going to say we have a triple bond in this molecule. Now, when it comes to naming this thing, we have 2 options. We have a methyl and we have an alkyne. We have triple bond here. The triple bond has a higher priority than other things attached. All right, so in naming it goes, alcohol gets the lowest number, then double or triple bond. Then after that, you just want to make the numbers as small as possible. So we're going to name this thing from left to right to make sure that this triple bond gets the lowest number possible. All right. When you name a double or triple bond, it starts from the carbon you first come from. All right. So this is carbon 2. The triple bond comes from carbon 2 to carbon 3. So in the name, we put a 2 on there. Now, this way here, it did it differently than I would have done it. So in my class, when you're doing it, you should actually say 4-methyl pent dash 2-ine. So let me fix that here in a few seconds here. All right. I'll come back to an example of that in a few seconds. Anyway, cycloalkanes, this is another way that we talk about hydrocarbons. Sometimes they make a ring structure. So whenever you have a ring structure where the carbon actually makes a whole circle, we just put a cyclo on the front of it. So cyclo just means a circle. All right, so here's cyclohexane. It's 6 carbons in a circle. Here's cyclopentane. Here's cyclopropane. So if they form a ring structure, then we put cyclo on the front of it. So when it comes to actually like chemical formulas, so it's a little bit different than the not the cyclos, because you actually have the carbons making bonds to themselves. So before, if this was just one long chain, the carbons on the end would have an extra hydrogen. But because it circles around and the first carbon attaches to the last carbon, we actually get rid of some hydrogens. So it's almost the same formula for the other ones, but now you'll see you actually have less hydrogens. So for a cycloalkane, it's N times 2 for the hydrogens. For an alkene, it's 2N minus 2, twice the carbons, minus 2. And for a cycloalkyne, it's 2N, oh, that should be 2N minus 4, my bad. So ignore that right there, it's 2N minus 4. Again, watch out. Do you want to know the formula or the molar mass? All right, I'm going to put some more examples out of some videos for naming stuff, but this should get you a little brief start for being able to learn how to name things. God's peace.